A newly studied planetary system appears to break the expected order of worlds, revealing an unusual arrangement that current theories struggle to explain. Many vile Earthlings munch jam sandwiches under newspapers, and my very educated mother just served us nachos may sound like nonsense, but they are classic memory tricks used to teach the order of the planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. These 8 planets fall into 2 broad categories: rocky and gaseous. The inner worlds closest to the Sun, from Mercury through Mars, are solid and rocky, while the outer planets, from Jupiter to Neptune, are mostly made of gas. Astronomers have long observed this same arrangement across the universe. Planet formation theories predict that rocky planets form near their stars, while gas giants develop farther out, and most observations have supported this idea. That was until scientists closely studied a system around a star called LHS 1903 using ESA's characterizing exoplanet satellite, Cheops. What they found could reshape how researchers think planets form. LHS 1903 is a small, cool red M-dwarf star that emits far less light than our Sun. Thomas Wilson from the University of Warwick and his international team used both space-based and ground-based telescopes to identify 3 planets orbiting the star. Their analysis suggested a familiar pattern: a rocky planet closest in, followed by 2 gaseous planets. But further observations with Cheops revealed something unexpected. Data pointed to a 4th planet orbiting even farther out, and surprisingly, this distant world also appears to be rocky. That makes this an inside-out system, with a planet order of rocky, gaseous, gaseous, and then rocky again. Rocky planets don't usually form so far away from their home star. Current models explain that intense radiation near a star strips away gas, leaving behind rocky planets. Farther out, cooler conditions allow thick atmospheres to build, creating gas giants. ESA Cheops project scientist Maximilian Günther highlights the importance of the discovery. Much about how planets form and evolve is still a mystery. Finding clues like this one for solving this puzzle is precisely what Cheops set out to do. Researchers were cautious about drawing conclusions from a single unusual system. They explored other possibilities, including whether the outer planet lost its atmosphere after a major impact, or whether the planets shifted positions over time. Simulations and orbital analyses ruled out these scenarios. Was the planet, for example, at some point in its past, hit by a giant asteroid, comet, or another big object that blew away its atmosphere? Or had the planets around LHS 1903 swapped places at some point during their evolution? After testing these scenarios through simulations and calculations of the planet's orbital times, the team of scientists ruled them out. Instead, their investigation led them to a more intriguing explanation. The planets may have formed one after the other instead of at the same time. According to our current understanding, planets form from disks of gas and dust, protoplanetary disks, by clumping into planetary embryos at roughly the same time. These clumps then evolve into planets of different sizes and compositions over millions of years. In contrast, here, researchers discovered a planetary system where the star might have given birth to its 4 planets one after the other, instead of bearing quadruplets at once. This idea, known as inside-out planet formation, was proposed by scientists as a theory about a decade ago, but until now, never has the evidence been so strong. This conclusion comes with an additional catch. Much like how our younger siblings are growing up in a world that is different from the one of our childhoods, this small rocky planet seems to have evolved and formed in a very different environment than its older sibling planets. By the time this outer planet formed, the system may have already run out of gas, which is considered vital for planet formation. Yet here is a small, rocky world, defying expectations. It seems that we have found first evidence for a planet which formed in what we call a gas-depleted environment. The small rocky world is either an odd outlier or the first evidence for a trend we hadn't known about yet. Either way, its discovery begs for an explanation that lies beyond our usual planet formation theories. Historically, our planet formation theories are based on what we see and know about our solar system. As we are seeing more and more different exoplanet systems, we are starting to revisit these theories. As instruments improve, we continue to discover more and more weird planetary systems in the vastness of space. They force us to question our understanding and make us reconsider established theories of planet formation. Ultimately, these discoveries are helping us learn about how our solar system fits into the big family of diverse planetary systems. They make us wonder how special the order of the planets is that we teach our children, and if maybe it is our home solar system that is the weird one after all. Thank you for watching. If you've enjoyed our videos, subscribe to our channel for there's more to come.